Okay, good afternoon, everyone. Okay, today is the 30th of September, year 2020. Following up the discussion of the definition of pressure, which is defined as the force perpendicular to the surface acting on a surface, okay, and divided by the area of the surface, and which has the unit of Pascal, and 1 Pascal is equals to Newton per meter square. Okay, we will use this concept in our gas laws, and so that it will be mainly deal with the motion of the gas molecules to produce this pressure, because when gas molecules bombard the walls of the container, when the molecules hit the wall, the molecules rebound, right? Rebounds. And so during this process, net force is acting on the molecules. And at the same time, the reaction force acting on the wall of the container. Okay, now we will have one more example before we move on. And we will deal with the example 4.2 on your textbook right here, 4.2, okay, on page 141. Example 4.2. Okay, our gas is trapped inside a cylinder with an airtight piston. It means air will not go into the piston or will not leak out of the piston. Okay, no air goes in and no air goes out through the piston. The weight of the piston is 8 Newton. Its cross-sectional area is 10 to power minus 3 meters square. I'll write these two down first. Okay. All right, and now assuming the atmospheric pressure is 100 kPa. Okay, I'll put ATM, subscript ATM to stand for atmospheric pressure. What is the gas pressure inside the cylinder? Neglect friction, and friction is 0, all right? So how to deal with questions like this, and we'll draw a simple diagram. First of all, the orientation of the pistons relative to the earth, whether it is vertical or horizontal, which is very important because it will affect the final outcome. Okay, so in this case, the question should state that the pistons is in the vertical direction. It can move along the vertical direction as shown in the diagram, like this. Okay, this is the airtight piston. And there is an orientation which is in the horizontal direction, like this. So these two scenarios are totally different from each other, and how we deal with them will be totally different. So you need to make sure whether what is the orientation of the piston in the first place. Okay, now that according to the diagram of this example, this is our scenario, our cases. Well, this is not. All right. So first of all, we choose a point, for example, just beneath the piston. And I'll call it point C, for example, a point X, for example. Right? Point X, for example. Then at point X, now the piston is in equilibrium. You can use two concepts. First of all, the pressure acting on P is 0, or acting from the side above X will be equal to the pressure acting on X below X, right? So I mean the pressure at X subject to is equal to two different measures. The one is the gas pressure, because it is inside the gas and under the pistons, where the air molecules will collide the point X, right? So at X, the Px is equal to pressure of the gas. Okay, some gas are trapped inside the piston, and so the point just beneath the pistons is equal to the pressure of the gas trapped inside this system, the container and the piston, right? Okay, and that should equal to the pressure acting on this point from above, right? And what is the pressure acting on X from above? There are two contributions, okay? Two parts. First, consider Y, okay? On top of Y, okay? On top of Y, there is atmosphere. So a column, you may consider that a column of gas is acting on that particular point Y. And so that at Y, we will measure the atmospheric pressure, because Y is in contact with the atmosphere. And so Y at point Y it should be subjected to the pressure of the atmosphere. Okay? And so point X should be equal to point Y, but there is a piston between them. And so the pistons will exert another pressure below, because the earth, there is a weight of the pistons, okay? Because the weight of the piston is being pulled down by the earth. And so there is a force acting on the piston perpendicularly, right? Which is weight of the pistons. And whenever there is a force acting perpendicularly to any area, there is a pressure, okay? And so the pressure and X can be observed or considered as two parts. The first part from the all the pressure above point X, and then the other part below, which is the gas pressure. And so we have Px equals to P-ATM plus P of the pistons. Okay, this is from the pressure's point of view. And at the same time, however, you can consider this case from the force's point of view. Now, the piston is in equilibrium, right? It's in equilibrium. There is no acceleration, and it is at rest. The piston is at rest, right? And so we can draw the free body diagram. We can draw the free body diagram of the piston. Free body diagram of the piston. And it is subject from the weight, first of all, and then the gas below the piston exert a force upward, like this. And then the atmosphere, all the gases above the piston will also exert a force downward, passing it down, okay? Like this. So this is the free body diagram of the piston. And according to Newton's first law of motion, because there is no acceleration, and so the net force in the vertical direction will be 0. And so we have F gas is equals to this two force pointing downward, right? And atmosphere plus weight of the pressure, right? So this is from Newton's first law of motion. And then we divided the equation, right hand side and left hand side, by the area of the piston. And so we have F gas divided by area of the pistons, okay? This value. And so this is the concept of the pressure of X. So it is pressure of the gas, right? Force exerted on the piston by the gas molecules below the piston. And this one, atmospheric pressure, atmospheric pressure. The last one, the weight of the piston will create another pressure, right? And so we can solve the problem now by illustrating the concept and the relationship between these three pressures as well as these forces. Okay? And so you are asked to find this one, right? You are asked to find what is the gas pressure inside the cylinder. You are asked to find this one. Okay. So, if you don't have question to ask, then which is equal to atmospheric pressure, this value 100 kPa plus the. So it is better to use the unit of Pascal directly, okay? So this is K, 1000, right? And pressure due to the piston, which is weight of piston over A. This one, weight of piston over A. And so it is 8 Newton over 10 to power minus 3. And then with your calculation, you have 108 times 10 to the power 3 Pascal, right? Or 108 kPa. Finish. All right, if you don't have question to ask, then I'm going to illustrate the horizontal scenario. What will be the pressure of the gas if we have a piston and a container, okay, trapping some gas inside, like this. Okay, now we have a gas trapped by a piston inside a container like this. The piston is airtight, no gas come in, no gas come out. And the friction between the piston and the container is zero, no friction. All right? And so consider these 2 points. Point A and then point B. Okay? The 2 points at both sides of the pistons. Since the pistons now is at rest, same as before the condition at rest. Okay, it does not move, no acceleration. And it means the force acting from the gas inside will be equal to the force acting from outside due to atmosphere, right? And so we have, and now you can see that the weight of the piston does not do anything here because the weight is in the vertical direction. So if the piston is fitted to the container horizontally like this, then its weight will have no effect on the gas pressure. So these 2 scenarios are totally different. And this one is very simple. We have the force inside is the force exerted on the piston by the gas molecules. The force outside, out of the piston, is the force exerted by the air molecules, by the atmosphere. And so the perpendicular force over area is the gas pressure, by definition. And the force of the air molecules out of the pistons over unit area should be the atmospheric pressure. So to conclude, if the piston is installed like this one, okay, its weight is to be supported by the wall of the container in the vertical direction, then the gas pressure in this case is simply equal to the atmospheric pressure outside, out of the piston, right? And secondly, if the piston is installed vertically like this, then the weight of the piston will cause some extra pressure acting on the gas. So the gas pressure will be the atmospheric pressure plus the pressure of the piston due to its weight. This part is weight of the piston over the area of the piston. All right? So I hope you appreciate how to do this calculation, and that's all for now for the concept of pressure, gas pressure, atmospheric pressure, so on and so forth. All right. So next step, we will move to 4.2 gas laws. There are altogether 4 of them, 4 gas laws. Right. So before we move on, any questions? If not, ask your questions, okay, immediately if you have any. If not, I'll raise the red bar, all right? Okay, and now I will draw a table consists of all these four losses and the most important parameters or physical quantities involved. And please draw the table by yourself too. And it should be something like this. All right, this is the initial part. The first law to be discussed is called the Boyle's law. Boyle's law, all right? Boyle's law states that if the temperature of the gas of a fixed mass of gas is a constant, okay? Last time we have talked about there are four physical quantities related to any gases, right? So we start from that point. The idea is this: whenever we talk about gas, we will talk about pressure, P, and then the volumes, V, and then the temperature, T. The last one is mass, or number of molecules of the gas, or number of moles of the gas. Right? So first of all, when we talk about these gas laws, we talk about a gas of fixed mass. And so these three will be constant. Okay? And now we deal with the other three physical quantities, which are pressure, volume, and temperature. All right? So first law, the Boyle's law, on page 144. Okay, we can prove this with experiment. Okay, however, we don't have such luxury. Okay, at this moment, actually, I have arranged experiment to prove a Boyle's law by yourself in a group of experimental setups. However, due to this pandemic, we are not allowed to do so. So we have no choice but to go on to teach you this without doing any experiments by yourself. All right, and I hope you can understand that all the laws to be discussed can be proved experimentally, okay, in our physics lab. All right. So the first one is that keeping T constant. Okay. The variation of the pressure versus volume will be like this. Okay. P is directly proportional to the reciprocal of volume. Or we can write PV equals a constant. Or we can write Okay, this is the equation to be used to calculate the change in pressure or volume for a constant temperature of a fixed mass of gas. Okay, between two different states. Okay, and the graph is like this. If we plot P against V directly, we will have a graph like this. Okay. However, in most of circumstances, because we know that P is directly proportional to the reciprocal of volume, we will plot a graph like this. P, instead of plotting P, the horizontal axis is chosen to be 1 over V, right? And so we can draw a straight line, okay, straight line. If we choose to draw against a 1 over V, right? So that's the Boyle's law, and we are going to have a discussion of the Boyle's law through one example. Okay, then we will have a stop, and then the next lesson we will discuss the other laws, right? So on page 146, example 4.3. Okay, 4.3. Air column in a syringe. A student tried to this one. Okay, this one. A student tries to verify Boyle's law with the setup in the figure. The initial volume and pressure of the gas column inside the syringe are 4 centimeter cube and 10 to power 5 Pascal. Okay, I'll write down the figures first. Okay, the question itself tells us the first physical quantities of the first state, which so I will write so pressure at the first state, okay, 10 to the power 5 Pascal. Volume of the first state, 4 centimeter cube. And then A, she pulls the piston so that the volume grows to 11 cm cube. So this is V2, 11 cm cube. All right. What is the pressure of the gas column now? So you're asked to find P2. Okay, mathematics here are not mathematics here. Usually not very complicated, because usually you are given the 3 physical quantities and you are asked to find out the 4th. Okay, by using this equation, this is the Boyle's law equation to be applied. Okay, so by P1 V1 equals to P2 V2, we have P1 10 to the power 5, V1 4 centimeter, and then P2 the pressure of the second state to be found, and this one 11, and so you can find P2 to be 3.64 times 10 to the power 11. Let's get. All right.好啦，咁就我哋仲有少少時間可以睇下先啊，仲有1分鐘到。好啦，我哋咧就 嗰個 A2同埋 B 咧，我哋咧就唔答住啦，好唔好啊？啊，我哋一陣翻轉頭再講啊。啊，咁呢度咧，你留意咧，我哋用呢個公式嘅時候咧，就因為咧佢就係 symmetrical on both side， 咁所以咧嗰啲units 咧，你就可以咧唔需要咧就轉做嗰個 standard unit 嘅。啊，譬如呢個 cm cube 啦 ，you don't need to change it into meter cube. You can keep this unit as long as they are equal on both sides. The units are the same on both sides. Then you don't need to change this and then change this one. Okay? cm cube can be used directly, provided that the other side use the same unit cm cube. All right? That's the point. Okay? And that's the when you apply this kind of relation or equations, you should notice that you don't need to change the units all the time. All right? So and I will leave A2 and B to the next lesson. So let us take a break first. All right? See you later in 5 minutes. And 有同學有問題喎，真係唔講嘢，講咩啊 ？So pressure difference 等於 force over area? No, of course not. 再講一次啦，同學，我個 mon 咧就好細嘅，你咧就打嗰啲 check 咧，我就有時咧留意唔到有人打住任何嘢，咁所以你最好咧就係開咪講嘢啦。如果可以嘅話，好嘛？咁啊頭先同學問咧嗰個 pressure difference， 即係一個 pressure 減另一個 pressure， 就係唔係嗰個 force over area 咧？唔係，每一個 pressure 都係 force over area。OK 啊 ，force 嘅 definition 就係pressure 嘅 definition 呢度就係 force over unit area 啊嘛，唔係個 difference。OK， 不過呢一題咧就有個 difference 點解啫嚇？好，我哋下一堂再見啦，留翻啲問題一陣間再討論。OK，see you later，拜拜。